Hello, my name is Brian Stone, and in this video I'll be showing you the enclosure that I designed and built for the Arduino that powers my Shapeoko 2. Even before I bought the Shapeoko, I knew that I would need an enclosure for the electronics, so I made this project a priority. Mostly, I just needed something to install cable connectors on so that I could run the cables to the stepper motors instead of having them permanently hardwired to the GShield. But I decided to go all out and make a compact, nice looking case, complete with a 70mm fan for cooling. I found some really nice mini-DIN 4-panel mount connectors on DigiKey, and then I went to work designing the enclosure in Autodesk Fusion 360. Fusion is a very powerful CAD/CAM program that enables amateurs like myself to build some pretty impressive parts on hobby CNC machines like this. Its ability to show you exactly what the part will look like as it's being milled is particularly useful. The model you just saw was my final design, but I made a previous attempt to mill out an earlier design and it didn't turn out so well. While the machine was on its final path to cut out the part, it got stuck and missed some steps. Right about there. You can see the X-axis became jammed momentarily, and it was probably a bit of wood under a wheel. As the router rounded the corner, it started cutting into the part, and it was done. I chalked it up to a learning experience. After that failure, I built a dust shoe for the router to contain the dusted chips. I experimented with a few materials for the dust shoe's skirt, including polyvinyl shower curtain, some laser printer transparency material per a suggestion that I received on the Shapeoko forums, and that worked out pretty well. But then I rediscovered some heavy vinyl fabric that I had left over from a previous project a few years ago, and this turned out to be a really good material to build the skirt out of. Vinyl fabric is pliable enough so that it won't interfere with the machine, but it's stiff and heavy enough to contain the chips. The first skirt that I cut out, unfortunately, wasn't long enough, so I extended it with a second piece glued onto the first one. The box is composed of 3 parts: the base, the middle riser, and a cover. The part being milled out right now is the middle riser. When I created the toolpaths for this part, I made the parting tabs just a little too thin and too narrow. It didn't take much for the mill to bind and break one or more of the tabs. When the router grabbed it, it shattered. Well, as they say, try again. I made the parting tabs a little larger, and the part milled out this time without any drama. The final part to mill was the cover, which I was very happy to have to only mill once. I milled these parts out of hard maple, which is one of the more common hardwoods available in the United States, and it's also one of the more durable ones. Even so, the middle riser was so thin and fragile that I broke it several times while I was cleaning it up. The assembly of the box is straightforward. The base receives 4 nuts in the corners that sit in recessed pockets to accept M5 bolts that will hold the cover on. Then the middle riser is glued to the base with superglue. The DC power connector is mounted in a bezel that I milled along with the base. Even though that left a hole in the middle of the base, that hole won't be visible once the cover is on, so not a big deal. A little sanding, some quick test fitting, and I was ready to assemble the electronics. The Arduino is simply fixed into the box with some double-sided foam tape. The small blue circuit board that you see here that I'm soldering is a DC buck converter. It takes the 24-volt DC input required by the GShield and converts it to 12 volts to power the 70mm PC fan. I applied some hot glue to the bare terminals of the buck converter to avoid shorts, added some zip ties to contain the wires, and it's finished. I still have some cable management to work out, and I plan to design a second electronics box that will house 6 more DIN connectors and will be permanently attached to the Shapeoko's enclosure. That will act as a bridge so that I can keep the enclosure completely sealed instead of running cables through a hole in the wall. I hope you enjoyed this video. I plan to make more as I continue diving headlong into the world of CNC woodworking. It's a great hobby, and I truly enjoy every minute that I get to spend with this machine. Hope to see you soon. Bye.